What if your agent could invent a faster tool from its own successful run? Welcome to AI Agents in Depth, Episode 8, Agent Self-Evolution. You'll build self-evolve, register a brand new callable at runtime, and prove it green with Pytest. You built reward function, last episode. Chapter 8 calls those records operational trajectories. Steps, final answer, expected min steps, same dict, no new format. Chapter 8 maps exactly 4 ways to encode experience. Open the source of truth, Boji Lai's book. Knowledge, instructions, programs, parameters. 4 modes that exact order. EP8 implements Mode 3. Mode 4 is what reward function feeds in a full training loop. It doesn't happen on camera. Now see all 4 quadrants drawn out. This is the full map of where self-evolve fits. Top, knowledge and instructions. Bottom, programs and parameters. Programs means register a new callable. Parameters means fine-tune model weights. That's the quadrant reward function feeds into in a real training run. Zoom into programs. This is the quadrant self-evolve implements. Watch what it promises. Turns a repeated solution into a callable instant dict lookup. No LLM call. Production has the model write the function body in a sandbox. We use a safe template instead. Your turn, zoom out, find the parameters quadrant. Press Ctrl- twice. Parameters, quadrant 4. Self-evolve never goes there. It only mutates the tool's registry. 0 effect on model weights. The extension point for self-evolve already lives in agent. Pi. Open it now. See tools near the top, a plain Python dict. Not a static registry, just a mutable dict. That's the whole extension point. We'll mutate it mid-session. Jump straight to the function that mutates the tool's dict at runtime. VS codes, find bar opens at the editor top. Fast file search, no scrolling through hundreds of lines. Type the function name. VS Code jumps to every match instantly. Every match highlighted. The body does 2 things. Appends to the tool description's string, that's unconditional, then sets the tool's dict entry. 2 mutations. Nothing else. Close find, and look at how the agent loop dispatches a tool call. Dispatch reads the tool's dict at call time, not at import. Calls self-evolve after a run. The next agent call gets the new tool, not the current one. No restart. Your turn, press Ctrl-F and search for the get stock price function yourself. You'll land on the EP4 registration. Name, description, input schema. The self-evolve function uses that identical shape. Same adapter, same dispatch. The mechanism already works. We're appending 2 things after reward function. A module-level cache first, then self-evolve. Files open. Both additions go at the bottom, stacking on every episode's code. Module scope means the cache outlives any single function call. Module scope matters here, and it is worth 1 beat to see why. Here it is in plain terms. A closure is a function that remembers the box it was born next to, not a photo of what is inside, the box itself. So when a later evolution drops something new in the cache, the tool we build sees it instantly. That is why the cache lives up here at the top. Now the function itself. Read it top to bottom, it is short. 4 simple moves. It only learns from a run that succeeded. We never bake a failed run into a tool. It pulls out the pattern that worked. It skips a tool it already built. Then it registers the new tool. No exec, no eval anywhere. In a real system, the model writes the body inside the Chapter 5 sandbox. Here we assemble it safely from a template. The closure is the key insight. No exec, no eval. The spec describes the tool for the model. Trigger phrase, return contract. 2 safety risks if the model writes the body. Arbitrary imports and file system access. The Chapter 5 sandbox guardrail provides safety. Encoding mode alone doesn't. Your turn, run this. Watch lookup-count appear in tools after one self-evolve call. True, lookup-count is live-in tools, no restart, no training. The agent just grew a new tool from its own successful run. Time to prove it works. We add 2 tests to test agent. Pi, 1 structural, 1 end-to-end. The EP1-7 tests are already here. We'll append to the bottom. Those existing tests must all still pass when we're done. PyDist doesn't reset module-level dicts. Without the cleanup guard, this test passes once then silently breaks on rerun. The cleanup guard runs first. Then we assert absent, evolve, assert present, assert callable, and assert it returns 3, the full before and after proof in 5 lines. The second test proves the agent calls lookup-count through the normal dispatch loop, not a direct function call. The stub calls lookup-count first. After the tool result arrives, it returns the final answer. The agent dispatched an evolved tool through the same loop it uses for every other tool. Every EP1 through EP7 test must still pass. The new EP8 tests must too. Let's run them all. All green. The 2 EP8 tests pass alongside every earlier test. No regressions. Appending new code never touched what already worked. Your turn. Press up in the terminal, then enter, and watch every dot go green. That's it. You built an agent that grows its own toolkit at runtime. No retraining needed. Next up, Episode 9, Multimodal and Real-Time Agents. Follow so you don't miss it. You've confirmed all 4 objectives today. You use the same trajectory dict, steps, final answer and expected as a learning signal, exactly as Chapter 8, Section 8. 1 describes. You map Chapter 8, 4 encoding modes: knowledge, instructions, programs, and parameters. You implemented Mode C, encoding as programs. The self-evolve function extracts the solved pattern, stores it in a module-level cache dict, builds a lookup-count callable as a pure Python closure, 0 exec, 0 eval, and wires it in via the episode 4 adapter. You named 2 runtime code risks, arbitrary imports and file system access, and the mitigation for both, the sandbox guardrail from Chapter 5. 2 tests locked in the proof. 1 asserts the lookup-count tool is absent before self-evolve fires and present after. The other proves the agent dispatches it through the normal react loop on the very next task. Pause here and try this. Write a trajectory where the agent called word count on 1, 2, 3, 4, 5 and got result 5. Call self-evolve with that trajectory. Then assert the lookup-count tool returns 5 for that same input. Quick check. Which of Chapter 8, 4 encoding modes did self-evolve implement? Programs, Quadrant C. We registered a new Python callable in the tools registry using the episode 4 adapter. Encoding as parameters, Quadrant D, is what the reward function feeds into in a real training run. That changes model weights and didn't happen here. Second question. Why must the duplicate guard come before the adapter call? Because the adapter appends to the tool description's string unconditionally. Without the guard, every call to self-evolve grows that string with a duplicate entry, confusing real models and breaking deterministic tests. Next up, Episode 9, Multimodal and Real-Time Agents. Follow so you don't miss it.